Good morning, everyone. This is LadyDragon speaking. It's Monday, January 27. It's 9:12 a.m. Now, we are going to do the keynote of NASA that returns to the moon and then to Mars program. And Artemis and Orion and all of sort of things about Mars and the moon and NASA. So, it should be extremely interesting and informative. Let's dive in right now.
All right, we were wondering how many people were going to be in the audience for this session, so it's good to see a good number of people. Hi, my name is Kristen Fisher. I'm a space contributor for CNN. I'm also launching my own YouTube channel called The Endless Void later this month. And I am just thrilled and honored to be sitting on stage with this panel right here. To my left is Reid Wiseman. He is the commander of NASA's next mission to the moon, Artemis 2. Next to him is Tyler Nestor. He's a senior advisor for NASA's Moon to Mars program. He's also the former chief of staff for SLS, or the Space Launch System. So I bring it up because it's pertinent to this panel. Next to him is Howard Hugh, program manager for the Orion spacecraft. And next to him is Rob Yeskovic. He's the associate manager of NASA's Exploration Ground Systems, or EGS. We'll simplify it. NASA loves acronyms, right? So we're going to use a lot of acronyms here. It is just such an exciting time to be in the space industry. I think the fact that you have a dedicated space panel with so many high-level NASA leaders and astronauts is really a testament to how far the industry has come. And just looking on the commercial side of things, you have two huge heavy launch vehicles sitting on launch pads right now. Blue Origin's New Glenn, SpaceX's Starship. I mean, the fact that these two are happening so close together it's so exciting. I mean, this was impossible just a few years ago. So that's the commercial side of things. And then we're here to talk about the government side of things. NASA's signature flagship program in particular, Artemis. And I think that's probably the thing that most people get the most excited about, sending humans back into deep space. But I will say, Reid, one of the questions that I get is people who are not in the space industry, but even people in this incoming administration, they ask the question, why go back to the moon? Haven't we already been there, and didn't we go there back in the 60s and 70s? So why go back again? How do you answer that question?
It's 1972 was the last time humans walked on the moon, and it was all Americans in the Apollo program. I think everybody would answer this question a little bit differently. To me, why go back to the moon? The answer, there's 1,000 scientific reasons, but really it is because we want to go to Mars. And Apollo was ahead of its time. It was brilliant. I was not alive then. I wish I had been to just watch what happened in our nation and the world. The entire world stopped to watch those landings, especially Apollo 11 and Apollo 8 when they first went around the moon. But we want to go to Mars, and we have an amazing resource right here, right next to us, a mere 250,000 miles away, our moon, where we can go practice. We can practice logistics. We can practice humans on the surface. We can practice landing with SpaceX and Blue Origin. And then once we have that proved out, we can get our way onto Mars. I love that you talked about Blue Origin and SpaceX, two heavy lift vehicles on the pad right now. And then right up the street from where New Glenn is, we are stacking the booster for the Space Launch System at Kennedy Space Center. So a third heavy lift vehicle is in the vertical and getting put together. And this is the technology that 10 years ago, especially on the private sector, I didn't dream about this technology. So exploiting this now, getting to the moon, learning about the science that we can, going to the South Pole, looking for water ice, learning how to aggregate that, power rockets, and then going on to Mars and answer these fundamental questions of why are we here? Are we alone? How was this all made? And getting humans out into the solar system. It's a brilliant time to be alive.
In addition to, just going back to the moon, there are, there's some real similarities between Apollo and Artemis, right? I mean, For one, the destination, but also the two names, right? Apollo and Artemis. Artemis is the twin sister of Apollo in Greek mythology, so it shares that nice little continuous thread. But there are some pretty significant differences between Apollo and Artemis in terms of the architecture, but also kind of the geopolitical implications of how the U.S. is going back. So Howard, do you want to take a stab at the question of just how Apollo and Artemis are different?
Yeah, I'll try. Let's see. I think first, the Apollo generation. I mean, it was amazing. The technology, obviously, at that time, and be able to land people on the moon for the very first time was just tremendous. And I think most of you probably know the history and the reasons why that was driven in the 1960s. For us, I think about three things that we're doing that really stands out a little different than what Apollo tried to do, which is put boots on the moon. For us, it's about science. It's about the scope of the magnitude of what we're trying to do. And the third thing is about sustainability. And when we talk about Artemis, we think about, number one, the remarkable science and unknown kinds of things that we're going to find when we perform science on the lunar surface. So that's really important. That's really one of the big drivers for what we want to do on the moon. When we talk about scope, and it was mentioned here by Reed and Kristen, is about how we're doing it, the infrastructure that's needed to perform long-term living on the moon. And it's really important. So not only do we have Orion, which is a transportation system, and SLS, which is the rocket that's going to take us to lunar orbit, it is about not only Gateway, our space station there, it is about surface habitats, it's about rovers, and all those contributions are a mix of government, international partners, and these private companies. And that magnitude, that scope, that complexity is what we're trying to put together, and that contribution through American leadership is making it happen not only in this country, but around the world. And so that's one of the fundamental differences. And of course, the last thing is about sustainability. Sustainability, meaning we want to not just land and put boots on the moon, we want to be there for a while. And that allows us to learn very close to our Earth about how we can do missions to Mars, where it is years away in terms of our ability to travel. And I think that's really the nexus and key of what we're trying to do between Apollo and Artemis. And I think that's the significant difference. And I'll ask Tyler if he's got anything he would like to contribute in terms of our infrastructure.
Yeah, the only thing I would add, Howard, is one of the big differences I see that you touched on is that we're looking at Artemis as, unlike Apollo, where they were seeking to send a man to the moon and return him this decade. We are building the foundations, as our leader says, to kind of put the capabilities in place from now through the end of time to enable exploration. That this is really a building block, and where we're going to harder destinations, 10% more food for Reed and his friends is not 10% harder. It's integer multiples harder. We're going to harder destinations, which requires launch systems unlike what we've needed before, and sending all of those things and all of that infrastructure to place requires kind of an industrial production capability and kind of leaps of technology that even Apollo did not need. And so we're asking more of the industrial base than has ever been asked out of the industrial base.
And I think, Kristen, that's very clear. For our perspective, as a government flagship program for NASA, American investment. That's what Artemis is. We're investing in that future, as what Tyler is referring to. And I think that's another aspect of what we're trying to do as part of this program.
So it's been over half a century since any humans have been to the moon. We're now 15 months away from the scheduled launch of Artemis 2. I have to ask this question. I'm not going to guess how you're feeling, Reed. I've made that mistake before with some of your other crewmates, but I am curious, how are you feeling 15 months out?
15 months out, we just made a big decision on the heat shield that we're going to go fly as is. I won't go into the technical details here. Maybe that's for later on, but I get the honor of flying with Victor Glover, Christina Cook, and Jeremy Hansen. Jeremy's Canadian, so he'll be the first non-US astronaut to go out into deep space, 250,000 miles from planet Earth. and we're fired up. We have a believable launch date in April of 2026, no later than launch date, and now we're hitting 2025, hitting the ground running. And I know I said it in my last answer, but just don't underestimate that feeling of going to Kennedy Space Center and seeing your spacecraft being assembled, seeing these American men and women that are wearing harnesses, hard hats, they're strapped in, up on large gantry, bringing in these booster sections and mating them. You see a picture of it, and it just, you're like, oh, that's a rocket. But when you're standing next to this thing, or you're standing next to Starship or New Glenn, it's inspiring just to be around that hardware, to see, I call it the arrogance of humanity. Like, I cannot believe we try to tame these forces and send humans that far off of our planet. But we are really fired up. Let's go.
Fired up. Okay, that's how you're feeling. So I'd like to do a quick status check with 15 months out. And just, I think it would be important, given this crowd, to just kind of explain all the various different components and how it works, and I'll be really brief on this. It starts with NASA's Exploration Ground Systems, the mobile launcher that gets this rocket into space, and then the actual Artemis rocket, so to speak, has two parts. You have SLS, the Space Launch System, that's the booster, the heavy lift booster that actually gets the Orion spacecraft, which is where Reed and his 3 other crewmates are going to be. That spacecraft sits on top, and that is then going to separate from the SLS booster a few minutes after lifting off. So it's super complicated. That's a very high-level overview. These guys can explain it much better than I do. But I'd like to just kind of quickly go down the row, starting with you, Rob, at EGS, and just kind of explain where you're at, what you're doing 15 months out.
All right, very good. No, so EGS, kind of high level, what you're talking about, our mantra is build, launch, and recover. And so from a build perspective, we're bringing in all the components, the solid rocket boosters, the core stage, Orion, and assembling those piece by piece in the VAB, putting them together, making sure that everything's working right. Then when that's ready, we'll roll it out to the pad, we'll fuel it, and launch it. And then a lot of folks don't understand that EGS is also the recovery piece. So when Orion returns off the coast of the Pacific, we'll work with the Air Force and also the Navy to recover the crew and the capsule and bring them back. Overall, you know, the progress that we're making, KSC and EGS right now are really a beehive of activity. We've had the mobile launcher out on the pad for quite a while, refurbishing it from the damage that was done during the Artemis 1 launch. That was a little bit more than what we had expected, so that took a little bit longer. While we were out there at the pad with the mobile launcher doing that, we also were testing the new emergency egress system, which is a new system for Artemis 2, in case the crew or the ground crews out at the, or I'll say the flight crew or the ground crews out of the pad need to be evacuated in an emergency. Also, the crew access arm is a new umbilical from the mobile launcher to the rocket. That is a system that we tested out there. So all of that has been tested. The mobile launcher came back to the VAB in October. We're continuing to refurbish some of the arms and umbilicals there. That's going very well. Reed, you mentioned the booster stacking. That started back in December. We've got a couple of the aft segments in place. We're actively working the others right now. Core stage was developed or delivered to KSC back in July. That was rolled into the VAB in a horizontal configuration. We did some of the work that we had to do with that. We've since rotated that vertical. It's over in High Bay 2 in the VAB, and Boeing is working on some of their final closeouts there, and that'll be ready to move over and join the solid rocket boosters later on this year. So some of the other things that we're doing out there, we've got some new systems with a 1.2 million gallon LH2 tank or liquid hydrogen tank out there. That's going to help us with our launch availability when we have a scrub turnaround or things like that, because there's so much liquid hydrogen that's needed. We needed a larger storage tank for that. So we're working through that right now. We're going through our pressure and leak checks on that, and we'll be filling that with liquid hydrogen to complete the development of that later this year. So we've got a whole lot of activity going on at KSC right now, getting ready to go.
All right, Howard, how about Orion?
Okay, from the Orion perspective, we actually put the spaceship together also at KSC, called the Operations Checkout Facility, and so a lot of great activity going on there. We're on really the back end of the spaceship. We've done a lot of integrated spaceship testing. We've got new systems for Artemis 2. So for Artemis 1, when we had a 25.5-day mission, in November 22. That was a flight test with really key systems like guidance, navigation, control, propulsion, power systems. With the crew on board, we're going to have life support systems, displays, and the ability, obviously, to fly the spaceship as well. So all those things are getting checked out. Very successful test. We're wrapping up what we call closeout work on the spaceship. In a few months, we'll get a chance to deliver the spaceship to Rob's team, and they will take it to the gas station. We'll start fueling the rocket, and then we'll stack it on top of the Space Launch System. And also in the ONC, we've got Artemis 3. We also have Artemis 4. And so we've got 3 spaceships in flow right now working through its various manufacturing production processes. And that's a really exciting thing. So certainly we're very focused on Artemis 2 and getting that spaceship delivered for launch, but we're also working very hard on Artemis 3 and 4 as well, and great progress there. Like Reed said, it's a beehive of activity. We're seeing a lot of things coming forward in terms of not only being able to get planning for the mission, wrapping up the vehicle, but all the new hardware that's needed for 3 and 4 arriving as well, and so that's been exciting.
All right, Tyler, let's get a status check on SLS.
From an SLS perspective, all of our hardware is now in Florida, and Rob has the lead. His team has the lead for getting it all stacked. We're supporting Rob as he gets it all put together and ready for launch. One of our big areas of focus, working with Howard's team, and then from a Moon to Mars perspective, the FOD team, is getting all of the specifics for each period that we want to launch. So the moon moves around the Earth. Each month it's in a slightly different place, and we have to have kind of specific software settings for each minute of each day we want to launch it in. And so because Reed's going further than anybody's ever gone from the Earth before, that's a lot of work to make sure each of those settings is just right. And so that work is very much in progress. That's not as visible as the moving the 200-foot pieces of hardware that Rob's team is doing, but nothing happens without that software working, and that's a huge bit of effort that is going on. Similar to Howard, the SLS folk have pieces in production all the way out through Artemis 9 right now at the various factories that is getting ready to backfill Artemis 2 as soon as Reed leaves, so we can get the next rocket kind of off the pad and onto the landing.
So Reed, I know there's no average day as a member of the Artemis 2 crew, but give us kind of the range of things that you're doing now to train.
First, I need to call these 3 out that none of them said paperwork. And I promise you right now, they are signing an unbelievable stack of paperwork as each of these parts are getting assembled and delivered. For the crew, our primary focus right now, well, I get to come to CES, so that's awesome. Haven't been to Vegas in a couple of years. We are primarily going through procedure reviews, which is fairly monotonous, but we sit in a simulator. Usually 2 members of the crew. We just take turns rolling through, and we are running every single procedure, every single failure that can happen on this spacecraft, and making sure that the spacecraft responds the way we want it to. We're also going out to a Lockheed facility in Denver, which has a really highly integrated test facility out there with the spacecraft, so we get to run the real mission hardware with the real mission software and see how that works. And then a little bit of it is academics, and a little bit of it is traveling around working with the US Navy, who will recover us, going to Kennedy Space Center and seeing the exploration ground systems teams assembling this vehicle. So every day is different. Every day is a little unique.
And you still get to have fun and fly those T-38s.
We get to fly T-38s. That's not bad. That's good training.
All right, so now on to the hard questions, right? Because, like with most things in spaceflight, especially human spaceflight, there are a lot of delays, and that is especially true for Artemis. And you guys just faced another delay of a few months. And a lot of that, there were a lot of reasons for the delay, but one of them had to do with Orion's heat shield. During Artemis 1, which was this the first uncrewed test flight back in November of 2022, if I have that right? There were some issues with the heat shield, more damage than expected. And so a few weeks ago, NASA announced that they were going to keep the heat shield on as is, essentially, for Artemis 2, but they were going to make some modifications. So Howard, my question for you is how confident are you that this heat shield on Artemis 2 is going to keep these astronauts like Reed safe when they re-enter the Earth's atmosphere at these insanely hot temperatures? And how confident are you that you can get it done by this new launch date, April 2026?
Well, I would say absolutely confident. You know, we would not put our crews on board a spaceship across all subsystems, not just the heat shield, if we weren't absolutely confident in its performance and with margin for safety. You mentioned the heat shield. You know, this is why we do flight tests. I think many of you know in your industries as well, prototyping and things like that. I mean, for us, flying integrated system in a very harsh environment is the final test. And so we were able to do that in Artemis 1. We were successful across, I would say, all the subsystems. The heat shield did exhibit behavior. This heat shield is made of a material called AVCoat that was also used in Apollo. We had to reformulate that material again. And the way we want to fly the spaceship and the way we need to have a repeatability in terms of where we land. Rob mentioned recovery off of San Diego, where in Apollo, you know, they landed anywhere in the Pacific Ocean, depending on when they launched. We want to make sure we're able to land off of the coast of San Diego repeatedly on every mission. And so we wanted to make sure we have a ability to have a trajectory and a capable heat shield that allowed us to do that. And so when we tested that on Artemis 1, and there's a lot of details. You probably, if you watch the press conference on December 5th, my boss, Amit, described it very well, but I'll just give you a couple highlights. You know, the heat shield normally, if you're anywhere familiar with materials, it's a ablator. And so there's as you get generated the heat, it's 5,000 degrees Fahrenheit when they come in at 400,000 feet. It ablates off chemically. And so that ablation process is really important to keep the temperature inside the cabin at roughly 68, 67 degrees Fahrenheit. And so what we found out was there was gases trapped when we were in a dwell period for about 800 seconds, where the gas built up and the char layer, the outer layer of the heat shield, didn't ablate as fast as we expected. And so therefore the gases became trapped, and you can imagine the pressure buildup inside from those gases, and pieces of that heat shield came off as we were re-entering. And so that was what we discovered. It was an unexpected behavior based how we wanted to fly the heat shield and how we want to fly our trajectory. And so that's part of the learning process we did. So we did extensive study analysis. We ran over 125 tests to show and demonstrate and really understand the physics. And this is a testament to our technical team. What NASA's all about, and our contractor team, is really finding root cause and finding and understanding the physics behind it. And so we spent a lot of effort doing that and doing the analysis. And maybe, I don't know, some of you would probably use your product. We do a lot of computational fluid dynamics, which requires high-end computing capability. That's a very difficult area in terms of modeling dynamics when you come in. Think about, you know, we re-enter with the capsule at 25,000 miles per hour. When we get to chutes, we touch down on the water at 16 miles per hour. So 400,000 feet down to the ground, 25,000 miles per hour down to 16 miles per hour, and at 5,000 degrees Fahrenheit. I mean, extreme temperatures, very hard to model. You've got a lot of turbulent flow. So if you're anywhere in that industry or you understand anything about that, it is really difficult. So we modeled that through analysis. We did through testing. We found the physical phenomenon, which we understand very well. And so by doing that, we know what triggers these kinds of events where we lose some of that char layer. We know that we can, on Artemis 2, we do not need to fly a certain type of trajectory. We can limit that ability we would have ability to limit that kind of char loss. And so from our perspective, you know, we had a path forward with the current heat shield that allowed us to fly the crew safely, keep the temperature in that 67, 68 degrees inside the cabin, which, by the way, Artemis 1, we had margin of safety for that. We had temperatures that were consistent to that, so we know that the crew had been safe even on Artemis 1 if they had flown on Artemis 1. And then going forward for Artemis 3, we've got a minor deviation or change in how we formulate the AVCoat. And so we're working on that. We're building blocks. For 3, we'll make the change on the heat shield. We'll fly more, I would say, complex, but more of missions and trajectories that we need to land the crew safely in San Diego. So we'll need that capability going forward. For Artemis 2, we can take a little bit more limits on our and constraints on our trajectory that allow us to limit the amount of spallation or loss of char that we're going to see. So I think overall great news. The technical team's done a terrific job over 18 months to really find the root cause and establish a path forward for us safely for Artemis 2 and going forward. So both not only with the current heat shield, but with the future enhanced heat shield going forward.
All right. So, did you want to say anything? No.
No, great answer, Howard. Thank you.
Sorry for the long-winded answer.
That was fantastic. You used 25,000 miles an hour at Earth interface, and I was going to use Mach 39 because 39 times the speed of sound. It just sounds so crazy to me. Like you just, as a career pilot, just breaking the sound barrier, Mach 1 is like this huge pivotal moment in a pilot's life, and we're gonna hit Earth's atmosphere at almost 39 times the speed of sound. Like the numbers just are hard to comprehend when you think through them.
Mach just sounds cooler,
It does.
right? You know. So Howard, you think Orion's going to be safe and ready by April 2026? Rob, what about you from an EGS perspective? Because there was a GAO, Government Accountability Office, report that came out last October saying that there were concerns that the mobile launcher, that there wasn't a lot of cushion in terms of the schedule. You've got a bit more cushion now with this delay. Is it going to be enough?
I think we're talking two different missions there, Artemis 2 and Artemis 4. So Mobile Launcher 2 is what the report was about for Artemis 4. But for Mobile Launcher 1 right now for Artemis 2, I think we're in really good shape. You know, it's in the VAB. We're working through the refurbishment and maintenance on some of the arms and umbilicals. We're stacking boosters right now. So from an Artemis 2 perspective, I think we're going to be in great shape and we'll be ready to go. If you're talking Mobile Launcher 2 for Artemis 4, GAO report did come out. We did have some challenges early on with that project. You know, that was awarded in 2019. And so just right off the bat, COVID hit in 2020, which was a real challenge for that team, for them to be able to get stood up and ready to go. And then inflation kind of drove some cost increases with that as well. You know, with the prime contractor there, getting their suppliers and subcontractors set up, there were some communication errors there. So performance really wasn't that great early on in the project. So understand the GAO's concerns there. Where we are today, I think, is we've kind of turned the corner on a lot of those challenges. We've retired a lot of that risk. One of the biggest things there, you know, we've taken some mitigation efforts. We took some of the work off of that contract so that the prime contractor could really focus on the mobile launcher structure and tower itself. Of the 11 umbilicals that were on contract with that contractor, we've taken 6 of them off to allow NASA and other vendors to focus on those, and we'll provide those to that contractor later on. So that reduced some risk there. We also really looked at contract incentives. The incentives that we had in place on the original contract weren't that great and weren't working that well. And so we've made some more objective contractual incentives there, which are really helping that team turn the corner. One of the other big differences is we have moved from the design phase into the construction phase. So if you think about design, the design was, you know, highly complex for the mobile launcher, and we've got 3 different programs that are doing concurrent design. We've got SLS, Orion, and EGS, and all of those affect interfaces on the mobile launcher too. That's kind of behind us now. We're into the construction phase, and we can really see that progress happening over this last year. Over this last year, they have maintained schedule on Mobile Launcher 2. The structural steel really started in earnest at the beginning of 2024. That was followed up in, I think, May of 2024, where they completed the jack and set milestone, which was basically taking the base of Mobile Launcher 2 and moving it from the temporary stanchions that it was on to allow them to do major structural work and putting that on the more permanent structure. So that was a really big deal. We brought the crawler transporter in underneath, picked up the base, and moved it over onto the permanent stanchions, and they hit that milestone early, so that was really good. Where we are today, just last week we had another major milestone, which was called rig and set, which is where there's multiple different building blocks of the tower. There's 7 modules total, and this was moving the first module on top of the chair assembly on top of the mobile launcher, and so that was like a 40 by 40 foot section that was completely outfitted. It's not just a structural, tower piece. It's totally outfitted with all the commodities and the elevator shafts and everything that have to run through it. Weighs about half a million pounds, and they were able to put that in place on time. So I think we've really turned the corner with performance on Mobile Launcher 2. We established our agreements with Congress earlier this year, or in mid-2024, and we're sticking with those right now. We're feeling confident with that, and I think we're going to be in good shape for Mobile Launcher 2.
All right, Tyler, the big criticism of SLS, one of the big criticisms has been just how much it costs. NASA's Inspector General has said that it's about $2 billion per launch, and it's totally expendable. You compare that with what SpaceX is developing with Starship. They estimate it'll cost around $100 million per launch, a lot cheaper than $2 billion. Of course, these are all big numbers that are being thrown around, but I'm curious, how do you justify this expense to taxpayers, the expense of SLS to taxpayers?
That's a harder question than you gave Rob. I would say that.
Sorry.
I would say a few different things there. I said my favorite assessment of how to answer questions like the one you just asked me was the one years ago when Mr. Hale from the Space Shuttle program wrote kind of a long blog article on how hard it is to give meaningful answers to questions like that in a soundbite and a short way that are accurate and really answer the question.
It's tough.
So if anybody wants to see that, I'd refer you to it, and I'll do my best, but I'm not claiming I'm Wayne Hale. So I don't agree fully with how that number you gave for SLS was calculated. That number, that's $2 billion, yes. Each year, if you go look at what Congress appropriates for SLS, it's on the order of $2 billion. We want to launch SLS rockets faster than we are. We want SLS rockets to cost less than they do. But in that $2 billion is a whole lot of stuff right now that is not just launching Artemis 2. That number you calculated was really, you get this much money each year, you're doing this much launches, so it must cost that much per launch. No. So I told you earlier that we were in the process of building stuff for flight articles out through Artemis 9. That means we've bought a whole bunch of metal and a whole bunch of rubber and a whole bunch of aluminum and a whole bunch of electronics. We have lifetime buys that we have done for many of our electronics components because we want those designs to be set. And so a lot of the costs that are in that number are things that we have already set. When you look at what do we think a recurring cost is going to be for, Wayne Hale kind of famously says the first one is $3 billion and the rest are free. Well, for anything in our program, if you want a human exploration program, there's a certain cost that has to be paid to have that, to keep the lights on, to run the factories. And then if you want another one, it's not quite free, but it's close. And so just because of the components you have to have in the pipeline. Relative to YSLS versus SpaceX, I think that is a false choice. To do what we need to do, we need all of the launch capability and all of the production capability that we have. And even then, we're going to be on the edge of being able to do everything that we want to be able to do and think we've been asked to do by the taxpayers. I think, like everybody who works on human spaceflight, we want to be going faster. We want to be doing it more efficiently. And we are doing that really every day. We're not where we want to be yet, but we're working to get there. And if you come and wire brush me offside the stage, or anybody does, I am happy with how we have spent the taxpayer money. I think we have done good by the taxpayers. I think we are wisely spending the money. I very much think it is defendable how we are going about that, and I hope that's not too many words, but I'm happy to give you more words if you want them.
Tyler, I was going to direct this next question at you, but I think it's going to have to be answered by somebody else. I want other people on the stage to feel your pain. And I realize that this is a topic that's touchy. I realize this is a topic that, you know, you guys don't want to answer, but I would not be doing my job if I didn't ask this question. So to either Reed or Rob or Howard, you know, you've got this new incoming administration coming in, President-elect Donald Trump, one of his biggest surrogates, Elon Musk, the founder of SpaceX. What is the level of concern within NASA right now that this new administration comes in and just completely alters either the architecture or the destination and say, hey, we're not going to go to moon, we're going to go to the Mars first? What's the level of concern within NASA about that? Who wants it?
I think I will take it. The specific question of level of concern within NASA, we work for the President of the United States. We work for the taxpayers. Those are really our two bosses. And with every change in administration, you get a little bit of a change or you get a major change in strategy or in tactical. And so the positives that I look, and there are many right now, is Jared Isaacman, who flew Polaris Dawn. He flew Inspiration 4. He's been I guess nominated as the administrator, and we know him well, and he's in human exploration. Elon Musk is probably the greatest inventor of our time, maybe of all time, and he wants to get to Mars, and we want to get to Mars, and we are on contract with his company, SpaceX, to get us onto the surface of the moon, which will prove out how we're going to get to Mars. So really, if you look at it, is there concern on an administration change? There is always. Every 4 years, you worry about that. You've been working really hard for a goal, and if that goal changes, well, you're going to have to shuffle the deck and come back and work towards the new goal. And being a part of, I mean, our little badges, oh, we're not wearing them, they say government on them. We work for the government. We do not work for profit, and we will do what we are told to go do. And right now, I would be remiss if I didn't say this is a golden age of human exploration, and we are going and doing great things. NASA is, and so is private industry, and we are all in this together. Now, many of my good friends work at SpaceX. They are launching my fellow NASA astronauts to the International Space Station about every 6 months and bringing them home safely. This is exactly where we wanted to be, and it's actually beyond where I thought we would be going in the next 10 years. So I look at it all right now very positive.
The golden age of human exploration. This is a perfect ender. We've got about 3 minutes left, and we actually have a countdown clock up here, which is great for this panel because we all know how to do a T-minus 3 minutes and 35-second countdown. But you say the golden era of human exploration in space. For the rest of you, what do you think that when people look back at this moment in time, 2025, what is this moment going to be in the journey for humans in getting off this planet? Rob, Howard, Tyler?
I would say for me, so I was giving this question a little bit of thought. You know, we had an all hands for the EGS team before the holidays, and we really talked about our accomplishments over the year and what that means and what it means coming into the next year. EGS is exploration ground systems, but the way that I put it, it's also energy, grit, and stamina, because that's really what I saw from the team throughout the year, and we're going to need more of that this coming year. And when I really thought about that is, what am I really pulling on there? It's the spirit. It was the spirit of the team. That's what they demonstrated. And for me, this is where we, all of us here, and even, you know, aerospace in general, it's the spirit of exploration is how I'd look back on 2025.
You know, Kristen, for me, I think the word I would use is nexus. I think looking at the crowd here, and, you know, I talked about American leadership. I talked about the scope of our work. I think it's really important that we, the world, and those who have the same ideals that we have and the same belief of peaceful exploration space are going together. And the ability for all of us to put our best foot forward relative to our intelligence, our technology, and all the commitments that we can make across the board in terms of our manufacturing capabilities are what is going to enable Artemis to go forward from what we did in Apollo to our new human space exploration for the world with American leadership. And that, to me, is the 2025 is the nexus. We talk about, you know, private companies that have demonstrated success with us for international space and delivering our crew safely is a really important thing. And now we are going beyond Earth. We're doing that together with not only those private companies, with the government, but also countries around the world. And when I think about this audience and I look at the people in the audience, you know, the we part is what I think about, and the bridging between what we did in Apollo to Artemis is what I would think about.
I'll be quick and leave some time for Reed. When I look forward at, if I look forward to when I'm a weeks older than I am now, I look back to 2025, I'm hopeful and optimistic that 2025 is the year that we look back on and that we decided that we were going to do exploration with humans, and we did the things we needed to do to make that happen. I am confident we're going to. We have the foundations in place to do that. It's an inflection point going from uncrewed testing and putting capabilities in place to actually sending humans into deep space. And this is the year I think we do that and put ourselves on the path to the moon and Mars. So I'm optimistic.
Reed, any final thought?
We look back in 20 years, this is the year that humans left Earth. And I think forever we will be off of Earth from this point forward. One quick anecdote, when you're on the International Space Station and you come up over California, you can see San Francisco at night. And if you just move your gaze just a tiny bit, there's this huge square of lights, and that's Las Vegas. And it cracked me up every single time I flew over.
Isn't it the brightest?
It's the brightest
thing on Earth.
You can see on Earth.
Right here. How cool is that? The Vegas Strip? And they didn't even have the sphere back then. So, you know, maybe you can see that. All right, we've missed our instantaneous launch window by like 30 seconds, but we're fine. Thank you guys so much. Thank you to Reed, Tyler, Howard, and Rob. Thank you guys so much.
Thank you.
Thank you very much.
I told you it was interesting. You see the commander, what he said at the end? He said, 2025, that's the year that the human race is leaving the planet, and they'll never come back. They're always going to be in space. I wonder if he knows the truth, this guy. I wonder. But I really like the way he ended this. This is very, very positive. Le commander, quand il a fini la conférence, il a dit que l'année 2025, c'était l'année où ce que les humains sortaient de la planète puis qu'ils seraient dans l'espace forever après ça. C'est vraiment telling ce qu'il a dit. Je ne sais pas si he's in the know, si c'est la vérité des choses. Mais j'ai trouvé sa phrase vraiment inspiring. J'ai trouvé ça très positif. C'est ça, il faut vraiment qu'il... J'aurais pas à dire, là, tout ce qu'on regarde, là, c'est des anciennes technologies, mais il faut qu'il fasse un bridge entre tout ça à un moment donné, là. I keep telling everybody, yeah, it's old technologies, but they have to do a bridge from the old to the new. So this is what I'm saying, bridges being built everywhere, on everything. C'est ça que je vois à CES, c'est pour ça que j'ai fait toutes les keynotes, il nous en reste 2 à faire. Il reste 2 keynotes à faire. Moi, c'est ça que je vois. Je vois qu'il construit des ponts entre toutes les vieilles technologies et les future technologies qu'on va voir. C'est vraiment, vraiment intéressant. OK, j'en vais dans 5 minutes. Il nous en reste 2 à faire. Be right back.